All right, so today we are going to study word problems. And, we are going to learn how to set up an equation and how to solve the problems, okay? In general, okay, the students are weak in algebra and weak in solving word problems, okay? So we need more practice. Once you get a linear equation, that's easy to solve, okay, as long as you be careful. The question is how to solve them, learn the correct way to do that. So solving a story problems, it involves 3 steps. Step 1, name the variable. Step 2, based on the given information, set up an equation. Okay. Step 3, solve the equation, then answer the question. Okay, that's it. So I'm going to prepare a list of the problems. I'm going to discuss one by one. Okay. So begin with the simple problems. Okay. Then we are going to study more complicated ones. All right. So the first problem says, Arian's grade in English class is based on 5 tests. Okay, 5 test scores. So she has scored 78, 76, 70, 84 on her first 3 tests. Now, what score will Area have to average on the last 2 tests to get an overall average of exactly 80? So we need to know how to find the average value, right? So you don't know the last 2 tests. So let's call T4 and T5, right? So you have a 78, 76, 84. Now, the average score of the last 2 tests. Okay, we know that, right? We don't know, that's okay. Okay, we have T4 and T5, okay? Then we add them together to get average value. 84, 60, 76, 84, and T4 plus T5. Okay, this divided by 5 is supposed to be 80. So that's the equation. From here, you will get the sum of the last two test scores. Okay, so just this part you can call it one variable, right? So what you do is T4 plus T5 is going to be 5 times 80, but you have to subtract the other 3 numbers, right? So minus 78 plus 76 plus 84. Now let's calculate this number. Okay, let's calculate this number. Okay, so 5 times 80 minus 78 minus 76 minus 84. So that is going to be 162. Okay, 162, not 170, 31. Okay, so the average score of the last 2 tests is going to be 162 divided by 2, which is 81. Okay, now this is a kind of linear equation involving 2 variables. Actually, just the sum of the last 2 tests. Okay, so this is the most general way. We do not assume the last 2 tests have the same scores. Okay, so we don't know what is the test score number 4. What is the test score? Right? The last test score. We know the sum. We know the average. Okay. All right, so for the rest of problems, we just name one variable. Right? We don't need to know. Most of the time, just have one unknowns. Okay. Most of the time, just have one unknowns. Okay. So let's take a look at the next problem. So Stephen has a collection of marbles in a pile. His little sister then took 10 marbles. Then his little brother put his own marbles into the pile, doubling the remaining marble. When Stephen counted the marbles again, he did not even notice any change. How many marbles were in Stephen's original collection? Okay, so name the variable. If it says how many, that's a question. Name the variable for the unknown in the question. So we can say X, okay? So that is X many marbles were in Stephen's original collection. So step one, X minus 10, okay? So that is, after his sister took 10 marbles. So this is the remaining amount of marbles, right? That's the remaining, okay? After the sister took marbles, 10 marbles, right? Now, then his brother is going to put his own marbles into the pile and doubling that. So when you double it, it's going to be, that's the total number of marbles now in the pile. And we were told that this should be equal to the original amount of marbles. So that is the equation we're going to get, okay? This is a remaining, right? Remaining, okay? After 10 marbles was taken, okay? And this 2x times x minus 10 is just double the remaining. And then it's equal to the original one. Then you from here solve the equations. 2x minus 20 equals x. 2x minus x is x, and 20, right? So the answer is 20, okay? Once you get the equation, you know how to solve it. Everybody knows how to solve it, okay? So when you see a story problems, step one, name the variable for the unknown in the question. You just underline this and put x there. Okay, use A or P, Then you read the question carefully and do some analysis on the data, and then you set up equation, then you solve the problem, okay? So let's try to do the next problem. A couple does not wish to spend more than $55 for the dinner at a restaurant, okay? That means you're already including the tax, okay? The tax or the tips or whatever, right? Right? So if a sales tax is 60% is added to the bill, then they're planning to tip 15% after the tax has been added. So usually people pay the tips about 15%, okay, based on the amount of the amount on the bill, including the tax already. So question, what is the most that they can spend for the meal? Now, what does it mean? This means this means the amount of money in dollars on the menu. For example, that dish cost $20. That soup cost $5. Then $25 that's what they can spend, because you have to worry about how much you have to add, tax, tips, right? So you have to solve the equation. This is the price on the meal, not the cost, not the final cost, okay? So when we say what is the most that can spend on the meal, they look at the menu, and that's all the numbers there, right? So this is the original. We don't know that. We assume that's X, okay? So first of all, you have to add the tax, 0.6. Okay, that is X. That's a tax. Okay, so total is 1.06X. Okay, that is the bill you're going to receive. Okay, the waitress will give to you. Right? So, but then you're going to add the 15% of tips. So that is the price, right, on the bills at the bottom of the balance. So you add 0.15 of that amount, which we don't know. So that will be the tip, okay? Okay, so add them together, it's the same number, right? So that's why it's 1.15 times 1.06. Okay. So this is amount of money eventually you have to pay, but you don't want to pay more than $55. So you can set this to be 55. Okay, then let's solve for X. Okay, let's solve for X. Right, so you know how to solve for X, right? So let's multiply this out. And 1.15 times 1.06 is going to be, okay, 1.219 times X equals 55. So from here, you can find the X, okay? So $55 divided by 1.219, and this is about 45.112. Okay, so that means if you order the meal less than or equal to that number, yourself, you have enough money to pay the tax, you enough money to pay the tips. Okay, this is the total amount of money. Okay, you can spend on the meal before the tax, before the tips. Got it? So you have to, it's clear, you know, when you do the homework, don't just work on the scratch paper. I want you to show all the details step by step. And I want to see the equation. Okay, that's very important. Yeah, if you make it very clear each step, even you get an answer which does not match with my one, and you still couldn't figure it out, then your parents can look at it and they can see where the mistakes quickly. Okay, that's very important. Okay, you must learn how to express it correctly. Don't skip steps. Don't focus on your goal to get answers. You have to show the solutions. Solution involves all the detailed steps. Okay, step by step. Okay, yeah, there's a difference between solution and answers. Answer is just a number. Solution include all the details. Okay, so let's look at the next problem. An auto dealer in a town sells car for a certain price plus a 6% sales tax. A rural dealer charges $300 more for the transportation, okay, more for the car before the tax, just because they're going to transport the car to the countryside. But the sales tax is cheaper in the countryside, the 4%. So if the rural car turns out to be $250 cheaper than the car sold in the city, in the town, right, after tax. So how much did the rural car cost before the tax was added? Okay. Yeah, look at this one. And my suggestion is the unknown is the price of the rural car. So how much? I call it X. So you list, right? So that is, yeah. And that is, yeah. So we just call it a city car. It doesn't matter. Okay, so okay, the car in the city. Okay, so now you trying to calculate. Okay, you call that one the X, and then you find the equation. Can you try to get the equation? Yeah. Yeah, trying to get the equation in X, then you solve it, right? So I'll give you a first step, okay? So that's because the car in the countryside charges $300 more. So you back to the city, the same car, the price will be X minus 300. Okay, that is the starting point. Now I wanted to calculate the difference of the final price after the tax is added. Rebecca, okay. Well, come on. Say, look at, you probably have no sense of the cost of a car. Yeah, typically the cost of a car right now, cheaper car is around $20,000. So when you get answers, yeah, look at the answer. Does it make sense or not? Okay, ask yourself. It does not make sense. Then you double check your work. Okay. I want to show to you until someone posts me a correct answer. All right, so let's do this problem. Okay. Yeah. I think Ivan's answer is correct. So let's do it. So we calculate, okay? So in the countryside, the tax will be 0.04, right? So add them together, it'd be 1.04x. In the city, this is a price, but plus the tax, okay, 0.06 of that price. So add them together, it's 1.06 times x, okay? Which one is supposed to be more expensive right now? We were told that the car in the city is more expensive, right? Yeah, the car in the city is more expensive. So we look at the difference. Okay, this is supposed to be 250. All right, then this is a linear equation. Okay, we're trying to solve it. Okay, so the linear equation is 1.06x, and then 1.06 times 300, and you can do the calculations, 318. Okay, so I will get 0.02x and 118 plus 250, right? Move this number to the right hand side. It's going to be 568. Okay. So from here, you divide 568 divided by 0.02, and let's use a calculator, and that will be, 500, right? 568 divided by 0.02. And that is going to be 28,400. Yeah, this pretty reasonable price. Okay, 28,400. Yeah, you can ask your parents how much this a brand new car cost. Some cost like this amount, some are cheap a little bit. Okay, I'm talking brand new cars. Okay. All right, so that is yeah, we named the variable. Now, if you denote by X the price, list the price of the car in the city, then don't forget that at the end you have to add $300. But sometimes people will forget it because they're so excited and solve the problem, then put the answer there. So it's better to name the variable for the unknown in the question. So when you solve it, you don't need to even check that. This will be the answer. Okay. Then, okay. So that's my suggestion. All right, so take a look at the next problem. Now, this is a typical problem I want to discuss in the class here. If somebody claim he learned the algebra in middle school, and this person should be able to solve this type of problems. Otherwise, you cannot claim you learn algebra. Algebra is basically about most important part of algebra is about solving story problems. And this is a typical story problem. Okay. Yeah, we are going to have 3 types of problems like that. Involve percentages of concentration, you know. Okay. So you have to draw the picture. Okay. And a chemist has 10 milliliters of a solution that contains 12% concentration of acid. How many milliliters of pure acid should be added in order to increase the concentration to 20%? Originally 12%, now become 20%. First of all, you have to understand, how do we calculate the concentration? The concentration, basically, percentage is going to be amount of pure acid over the total amount of solution, multiplied by 100%. And that is a concentration percentage, okay? So here's a formula, okay? The amount of a pure acid, and that is the total amount of solution, multiplied by 100%, okay? Okay, and that is gives the concentration. Okay, okay. So we don't know how many milliliters pure acid should be added. So we call it X. Okay, I said name the variable for that known in the question. The next step is how to set up equation. Okay, how to set up equation. And then the question, how do you calculate the 20%? So 20%, right, is going to be, you know, if you multiply by 100%, you should get 20%, right? That's our goal. So the denominator is the total amount of a solution. Originally, there are 10 milliliter solution there. Now you add X milliliters of pure acid. What is total? 10 plus X, right? The numerator, you have to calculate the amount of pure acid. Amount of pure acid part from the original solution, part from the added solution, added pure acid. Okay, so this will be X. That's a pure, right? The pure one, right? You add it. And okay, from this 12% concentration solution, there are 0.12 times 10. This amount of, right, is a pure solution, is a pure acid. So that is the equation you have to set up. The remaining part is easy, just solve this linear equation. Okay, that's a linear equation. Okay, so you can get, let's simplify a little bit. You know, you can get 1.2 plus X, 10 plus X, and divide both sides by 100%, that's 0.2, right? You know, right? Then you multiply it out. So then you multiply this out, it's going to be 2 plus 0.2x. Okay. So now you move this term to the left, right? So x minus 0.2x equals 2 minus 1.2. So that'd be 0.8x equals 0.8. So x is going to be 1. So you're going to add 1 milliliters of a solution into the container. Okay. Okay, clear, right? So the you have to use you needed to you need to set up equation based on the based on the concentration, the percentage. Okay. So now let's take a look at the next problem. It's a similar type, but it's a slight different story here. Okay. A reactor contains 10 quarts of a mixture of water and antifreeze. If a 30% of mixture is antifreeze, how much of the mixture should be drained first and replaced by pure antifreeze so that the resultant mixture will contain 45% antifreeze? Okay, 45% antifreeze. Okay. Okay, so draw the picture. Okay, so let's understand the problem here. This is a container, it's already full. You cannot add a pure one to increase the concentration. It's a full, it's a 10 quarts. So you have to pull out some first, then add some pure. Okay, so you get replaced by, yeah. So how much of a mixture should be drained? It's X, we call it X quarts. Okay. And this will be drained X quarts, right? Then replaced by, right? That X quarts of pure antifreeze. So that's why this tank is still full, right? Understand? Okay. Then imagine, right? The original antifreeze, right? It's a 30%, right? Concentration, right? So that is drained out, then, right? Then you replace it by the pure antifreeze, so you increase the concentration from 30% to 45%. Okay. So how do you solve the problem? How do you set up the equation? I think you needed to calculate, okay? You multiply this by 100%, you want to get 45%. The question, how do you calculate this 45%? Okay, what is the denominator here? What is the denominator? The denominator is amount of solution in the container. But that's never be changed, right? It's still 10 quarts. So the denominator actually is very simple here. So the only thing I have to make changes about the amount of pure antifreeze in the container. Amount of the pure antifreeze in the container. Part is from the original. Whatever is left, the remaining origin of the original and right, original mixture. And the part is from the pure antifreeze added, right? So let's add, okay, this is X, that's a pure antifreeze. Now, the antifreeze we got here is 10 minus X, that's the remaining amount, multiplied by 0.3. Okay, so 0.3 times 10 minus X, (0.3) times 10 minus X. 10 minus X is going to be, plus X, okay? So that is the result, right? So that, you see, 0.3 times 10 minus X, 10 minus X is the remaining amount of original mixture. And multiply 0.3, this is how much pure antifreeze there, right? They add them together, okay? This is the added part. Okay. X is the added part. Okay. So once you get this equation, the remaining part is trivial, right? 0.3 10 minus x plus x divided by 10 equals 0.45. Then I multiply both sides by 10. And I get 4.5. Then here's a 3 minus 0.3x plus x equals 4.5. And simplified, I think it's 0.7. X, 4.5 minus 3 is 1.5. And finally, I get x. Okay, so that is, if you use a calculator or by hand, you can, it's about 2.14. Okay, so I did not see anybody give me the right answer. Unfortunately, this is a problem. Okay, so you need to practice. You need to practice. This is otherwise you cannot claim you already learned algebra in middle school. Okay, so this is a requirement. How to calculate the percent. You know, the formula is very simple. How to calculate the concentration, amount of a pure acid divided by total amount of a solution, multiplied by 100%, and equals the concentration percentage. Okay, right? So sometimes the denominator has changed, sometimes it's not changing. Like in this case, the denominator is not changed. But the numerator is, of course, always changed. Okay, otherwise you're not going to change the concentration. All right, that's not always. Sometimes, you know. Okay, for example, if you have a certain type of solution, you don't have any other solution of a high concentration to put in. How do you make it more dense, right? You know, you can bring the concentration from 20% to 30%. You have to evaporate. The water should be evaporated out. So you reduce, you get rid of some water, but the active ingredients remains unchanged. So in this case, the denominator will be changed. Okay, but we're not going to do this problem. Okay, so that's 3 different type of problems we have to deal with. All right, so now let's do this different. Okay, 8 years from now, Elaine will be twice the age she was 3 years ago. Now, what is her present age? Okay, can you do this? Name the variable. Step 1. Name the variable. Okay. Yeah, when you get an answer, ask yourself, does that make sense or not, right? So usually this is about the student's age, so middle school kids. So you should get the age number, which is very similar to the, you know, pretty common, right? 13 years old, 14 years old, you know, right? So write down the equation first. What is the present age? I think X, okay? So let's see now, okay? And 3 years ago, okay? And here in 10 years, in 8 years, okay? So now is X, right? 3 years ago, X minus 3. In 8 years, X plus 8, right? So now what we're told, 80 years from now, Elaine's age will be twice of the age of 3 years ago. So X plus 8 equals twice X minus 3. Okay, so that's the equation I want to see. Then you multiply this out, 2x minus 6. And I think move 6 to the left, so 14, and x equals 14. Okay, so the equation is very important. Okay, this is what I want to see. Okay, when you do the homework, you have to write on the equation. All right, remember, step 1 is always name the variable. In general, it's always the name of the variable for the unknown in the question. Okay, then you draw the chart sometimes and analyze the data. So that's the second step, actually. That's the third step. You know, step 1, step 2, step 3, step 4. solve the equations. 4 steps. Okay, that's in general. Okay. All right, so now I wish you can work out this. This is a little bit challenging. Right. So N and Sam have the same grade average before the final exam. Okay. Final exam counted as a 25% of the semester grade. N got 5% points higher than Sam on her semester grade. And the final exam was worth 100 points. What is the number of points in the positive difference between their final exam grades? Oops. Okay. Yeah. So, we have a test scores. We have a final exam. Okay, let's see. The final exam was worth 100 points. Okay. We also know that final exam counted 25% of the semester grade. So how many points for the test? I think it should be total, it should be 400 because 100 out of 400 is 25%. So that should be 300 total. Okay, total 300 points for the tests. Maybe there are 3 tests there, test 1, test 2, test 3. Okay, or maybe there are 6 tests there, 50 points each. Usually tests have less scores. Okay, final exam have more scores, right? Maybe there's 6 tests there, 6 quizzes for you now. Okay, so this is going to be 25% of semester grade, so 400, right? Clear? So that's my hint, right? So now, how to solve the problem? Okay, we're trying to figure it out. So we don't know how many points N got, how many points Sam got, right? But they have what that says, they have the same averages, the same average. If they have the same average, they have the same total scores. Okay, so we just call the X as the same. Okay, those are same total scores. Okay, total scores, not the average score on each test. We don't know how many tests there, right? Total score, usually it's more than 300. Okay, let's analyze that. We don't know, but they're same, identical. That's okay. Final exam, Sam got, N got 5% points higher than Sam. So 100 points, you can have 100%, right? Right. So that would be N, that would be Sam. Okay, Sam got 8 points. N got 8 points, Sam got S points. Okay, what is the number of points in the positive difference of the final grades? We have to write down the equation. Actually, we want to find out. Yeah, we want to find out the positive difference between the final grades. The final grades, maybe one got A, other one got S, many points. So we want to find out is A minus A or S minus A. I think so. Yeah, just assume that's the difference. Okay, find the difference. Now, how do you find this? We have to use another condition called N got 5 percentage points higher than the same. So how do you calculate the 5%? Total 400 points. So N got, okay, X plus A divided by 100, 400 multiplied by 100%, right? That's a percentage overall. right? Minus X plus S, 400 times 100%. That's supposed to be 5%. It's a difference, right? That's what it says. And got 5% points higher than Sam of the whole semester. The whole semester should be calculated in this. The number of the points from the test plus the number of points from the final exam. Okay, now you simplify it. But once you simplify it, you notice that X will be gone. So what you get here is X, A minus S divided by 400 times 100% and equals 5%. Okay. So after simplifying, you will get A minus S is going to be 20, okay? Because on both sides divide by, multiplied, divide by, it's easy to see that. 100% divided by 400 is 104, 104 times 5 is 20, so it's 20. So A minus S is 20, that's the difference. You don't know the exact value, how many points N got on the final exam, how many points Sam got on the final exam, but you still get it. Okay. So the difference, you can tell the difference. But this is a little bit complicated. You have to, write down clearly in order to understand the problem. The remaining problems may be very natural. Okay. So the average weight of 5 packages on a scale is 9 pounds. When one of them is removed, the average of the remaining 4 packages is 8 pounds. What is the weight of the pounds in pounds of the package that was removed? Wow. All right. There are many packages here, 5 packages. We don't know the exact weight of each of them. Okay, it's going to be 5 times 9. Okay, right? 5 times 9, total is 45. So based on the first one, we know the total is 45. Okay. And we also know that after we remove the 5th package, we know the average, right? It's going to be 8 pounds. So 4 times 8 is going to be 32. So that is equation 1. That's equation 2. Equation 1 minus equation 2 is going to be just P5. That's a 45 minus 32. It's going to be 13 pounds. Great. All right. So that is much easier. You see, the similar problem, you see, you don't know all the details, but you still can figure out the one particular things. Just like above problems, you even don't know lots of things. A, you don't know. What is X? You don't know. S, you don't know, but you know the difference, A minus S. Okay. All right. So move on to the next problem. So a physical therapist's basic hourly wage is $28, but she receives 1.5 times the hourly rate for any hour work in excess of 40 hours per week. If her paycheck for a week is 1,414, how many hours of overtime did she work? Right? You probably don't know that. In the United States, in general, the maximum number of hours you can work is 40 hours because 8 hours times 5, 8 times 5 is 40. But some nurses, some health workers, they're required, they beg them to work longer time because weekends, right? You cannot go home, right? Sometimes the weekends still very busy. People cannot be sick during the weekdays. Sometimes more likely weekends, right? More people get sick maybe. So they have to work weekends. And how to make them to work? You cannot just force them to make work, ask them to sign up. So say if you work extra time, then you get more pay, hourly pay, okay? So can you write down this equation? So overtime, now first of all, we want to make sure it's overtime, okay? If it's just 28 times 40 hours, right? That's hourly pay times 40. And it will be less than it's $1,120. So it's less than $1,414. Okay. So that is okay, that is what we have. Yep. So definitely he's, you know, how many hours, right? It's overtime. So the numbers of hours overtime is called X. Now, can you write down the equation for that? Okay. Can you write down the equation? Yeah, I wish someone can give me the equation. All right. Right, let's calculate the total amount of money she's going to make, assuming the extra hour overtime. All right, so let's do it. So we assume, right? First of all, this how much money she's making is this money, right? Plus overtime. Overtime, the hourly rate will be 2/3, 1.5 times 28, and multiply by X. That's it. You know, then you get 1,414. Okay, so if you multiply this out, oh, this hourly pay is pretty high. It's $42 now. Okay, and here is 1,120. Okay, so 42X is going to be, okay, so simplified, it is going to be 294. Then X is going to be 294 divided by 42. And about 7 hours. So it's less than 1 day, right? Just work 7 hours. Okay. All right. So the next problem. Okay, let's do the next problem. Each of the 3 vases contains 30 flowers. Some flowers are to be removed from one vase and placed in another one to make the ratio of the flowers in the 3 vases 7:5 to 3. What is the list number of the flowers that need to be removed to accomplish this goal? Okay, so let's think about, okay, 30, each of them contains 30 flowers. Okay, we're trying to keep the 30 here in the middle. Okay, so we move 30 minus n and add it to this side. Okay. Right? We hope we can solve this problem. Right? We hope we can solve this problem. Sometimes it does not work. In that case, you have to remove some in the middle. Right? Remove some in the middle. Okay. Yeah, sometimes it works, okay? We want to make sure 30, then you have to remove the more, 32. Okay, it's gonna be 7 to 5 to 3. Let's try, okay? So that means if you use a ratio problem, you always introduce a variable t here, 30 equals 7t, and 30 minus n equals 5t, yeah, and 3t. Okay. So from in the middle, from here, you find out t equals 6, okay? And then you shouldn't get any contradictions. Otherwise, you're going to have a problem here. So from the first equation, 30 plus n equals 7 times 6. And here, 30 minus n equals 3 times 6. I want to make sure that gives you the same value. Otherwise, you have to redo the problem, okay? So n equals 7 times 6 minus 30. It's 12 by the first equation. That's equation 1, equation 3, equation 2, okay? By the first equation, yeah. So for this type of problem, you have to be very careful. Otherwise, you have to modify it. Okay, second equation is going to be n equals 30 minus 18. Great, that's both give you the same n. So that means, okay, you're lucky, we just move one number to another number, okay? Then keep the middle in the unchanged. So then you get the ratio you want. You get the ratio you want, okay? Okay. So I still want to go back to the problem, okay? And let me describe the problem. If you have an alcohol, right? We do that, when you buy the alcohol, it's sometimes on the market because for the coronavirus, right? It's 90% alcohol. So when you get home, we're assuming you're going to evaporate some water. If you find a device, you can add the waters, okay? And suppose this is we assume that 36 ounces, okay? So now you were told that from some article says that 70% alcohol is good for killing the coronavirus. So you cannot use the 90%. Sometimes looks like strong. Does not mean immediately kills the virus, because if it's too strong, probably the virus feel like, oh, something coming, let's just protect themselves quickly. Then you cannot kill them instead. Okay, when the alcohol is gone, they're still coming back alive. So 70% that don't feel so strong, but they get into the body, then they kill them. Okay, that's my understanding. So question is how much water you need. Okay, X ounces water is added, should be added. Okay, should be added to change the concentration from 90% to 70%. Okay, so please do this problem. Okay. From 90% to 70%. Okay. Yeah, please work out this one. This is a very practical problem, right? This is a place where mathematics is used, right? Do you agree, right? That's typical. We bought some alcohols from markets. We sometimes run out of the 70% alcohol, solution, and I have to buy 90%. I bought the bigger bottom. Then I have to do the calculation. There's some water. Not exactly. If you really want to get exactly 70%, you have to really measure it, okay? But you have to at least get some rough estimate. So can you do that? I can help your parents finish this project. Okay, clear, right? You have one bottom, 6 ounces of alcohol, 90% solution. Another option is in the future, you have a device, you can evaporate, steam it, let the water is gone. Then how much water should be evaporated in order to increase the concentration, right? but that's increasing. We're going to decrease the concentration. It's a different story. If you want to reverse this procedure, 70% of solution, right, to 90%, you have to evaporate. So what should be evaporated? All right. So please work out this problem. I hope you can do that. Okay, nobody gave me the answer. I have to do it here. Okay, so think about that, right? After add X ounces water in this container, right? So total amount of solution will be 6 plus X. All right. But this time you add this water, so it does not change the pure alcohol, amount of pure alcohol. The amount of pure alcohol is going to be, right? Amount of pure alcohol is going to be 0.9 times 36, right? And then if you increase the denominator, you're going to decrease the concentration. So that should be equal to 0.7. This is all about, okay? So you have to get this equation, okay? So now the question is how do you solve for X? Does not look like a linear equation, but actually it's a linear equation. 0.936 equals 0.7, 36 plus X. Okay, so so you multiply this out, you will get 0.7. Don't do the multiplication immediately because you will see, I'll tell you why, because 0.9 times 36, there's another one 0.7 times 6. So when you do subtraction, okay, when you do the subtraction, you get this. All right, so then you order, so you get 0.2. That's much easier to do the computation. Okay, so 36 times 0.2, right? It's going to be 7.2, right? 36 times 0.2, right? 7.2 divided by X is going to 7.2 divided by 0.7, okay? Divided by 0.7. It's about 10 ounces to 0.2. So even, it's about 10.28, okay? So 10.28 is slightly less than 1/3 of the 36, okay? So if you want to do rough estimate, you just add a slightly less 1/3 of the original amount, right? And then you get concentration about 70%, and then you can use it for the. That's what I did for the alcohol I bought. 90%. Then I have no choice. Then I do the calculation. Then I measure it, and then mixed up. Then it's get 70%. Okay. So this is a place where I use mathematics. You will see that, even elementary mathematics can be very useful. More advanced mathematics, use them in more other areas. Okay. So I'm going to stop here.